Yogi, am I audible?
Yes, sir, you are audible, sir.
Hello?
Yeah, sir, audible, sir.
Sir, you are audible.
Okay, fine.
Okay, sir.
Just it's almost 6 o'clock. We'll wait for another 3-4 minutes and we'll start the session.
Sir, shall we start, sir?
Yeah,
Hello?
1 minute, Yogi. Yeah, 1 minute, Yogi.
Okay, sir.
Good evening to all of you participants. Welcome to this fourth day sessions. Today we have two very good sessions. We planned in such a way that one is Dr. G. Venkat Rao and another one is Engineer R.K. J. Gopal. Okay, he's the IIB President of Karnataka. So the first session is in regard to the Venkat Rao. I'll just introduce Venkat Rao to you. Yeah, Sri Venkat Rao Garu is a post. 1 minute. Just. Yeah, Venkat Rao.
Hi, sir.
One brief introduction about Rao did his MTech in remote sensing and GIS from NIT Warangal. Then he did this PhD from NIT Warangal. So presently is having postdoc position in South Methodist University, Dallas, US. And earlier, he worked as a assistant professor in Vardhaman Engineering College. He is a visiting scholar to Virginia Tech University, US, and he's having research fellowship in Space Application Center, Ahmedabad, and also IIS, Indian Institute of Remote Sensing, Dehradun. He is having several journals to his credit, and also he has attended so many conferences, and he lives in US. It is early morning to him. Even then, he's sparing his valuable time to see all of you. Okay, thank you very much, Venkat Rao, and over to you, please. Now you take on the session, please. Thank you very much. Yogi and Raghu, please coordinate.
Yes,
Ma.
yes, sir. Yes, sir. Yes, sir.
Okay, sir.
Yeah. Thank you, sir. Thank you for brief introduction about me. And yeah,
Yeah, Dr. Rao, can you able to share your screen?
yeah, I'm sharing. I'm sharing. Are you guys able to see my screen now?
Yeah, yeah, sir.
Yeah. So, good morning. Good evening to all of you. So, as Sisda sir gave a brief introduction about me, so myself is Dr. Venkat Rao. So, as Sam mentioned, I did my master's and PhD from NIT Warangal, and currently I'm working as a research associate at Southern Methodist University, Dallas, in US. And I welcome all of you to this today's session on disaster assessment, monitoring, and prediction using remote sensing and GIS. This is the seventh lecture in the series of emerging trends in civil engineering for disaster management. And as I mentioned, this is the seventh lecture in this emerging trends in civil engineering for disaster management. So by this time, you all might be well aware about what is a disaster and how the mitigation or the management can be done and all. But to give a kickstart to our today's session, I'm just going to touch a brief basics on the disaster and its management cycle. So disaster is a sudden catastrophic event that causes a significant damage to the property or a destruction to the property or a loss of life. So if it is if it in the disaster, if these aspects are not included, like the damage, destruction, or a loss of a life, then that one will be considered as a hazard. And if there is a loss or a damage to the property or human lives, then it will be called as a disaster. And these disasters are classified into two categories. One is natural disasters, and here nature is the primary force for causing all these disasters, and which ranges from tornadoes to the sinkholes. And among all these, the droughts and the floods are the most common natural disasters in India, and some portions of the country will experience the avalanche, like majorly in Himalayan regions, and the sandstorm in some desert areas, and very rarely the tsunami. So these are the some common natural disasters that are happening in India. And the other disasters are the man-made disasters. So as I mentioned, so if any event that includes the loss of damage, the damage to the property or a loss of life, that can be called as a disaster. So the damage to the property that includes even the motor vehicle or automobile, for example, the transportation accident. So if there is an accident happen, then there will be damage to the vehicle, whatever the vehicle involved in that accident, and that when there will be damage to the people who are in those vehicles. And also even those kind of events are also will be considered as the disasters, but the magnitude will be small. So the man-made disasters are more vulnerable because those will occur very frequently, and among these, the transportation accidents are very frequent, and which has the more damage. Though if you look into the single event that has a small magnitude, but when you aggregate all of them, then it has a huge impact, even comparing to the other man-made disasters. But none of these will cope up with the natural disasters. And here are some examples of natural disasters. And if you recall the recent massive floods in Kerala, like there were recent massive floods in Andhra Pradesh and Telangana earlier this year, but unfortunately, the high-resolution satellite images were not revealed to the public. So the only high-resolution satellite images I could found for the latest the flood events were the Kerala flood events that were happened in 2018. And if you look at the satellite images, these are the satellite images for some locations in the Kerala state before the flood events. Like they took these pictures in March 2018, and these are the satellite images after the flood events. So the floods were occurred in August 2018, and if you look at these images, so all the gray portions are the areas that submerged underwater due to those massive floods. And this is another example of another natural disaster, which this one happened very recently in Kerala. That is a landslide, and the landslide was occurred in the upper portion of all those villages, and which caused a significant damage for the people who are living in the downstream areas. For example, so if you look at the above satellite image, so here the landslide was happened and all the debris were flown up to this portion, and this is the satellite image after the landslide. And if you look into the closer look, so here is a closer look for one section of that particular the landslide area. And if you look at this particular image, this one was taken before the landslide, and there are so many buildings or houses, or this is a residential area. And if you look at the same residential area after the landslide, all the buildings got vanished. So that is the impact of the landslide can have on humans or on a property. And here is another example of man-made disasters. And now everyone is familiar about the wars between the two countries because of the ongoing wars across the world. And this is one of the image for ongoing war. And this satellite image was taken before the war, like October 25, 2023. And for the same area, the satellite agency released a new image after the war. And if you look at the new image, so everything got vanished, and there is no proper, even the road facilities and all, because of this war, everything got vanished. So to minimize or to assess the impact of these disasters, the effective way is to assess the impact of these disasters is having a disaster management cycle. So the disaster management is defined as the discipline and profession of applying science, technology, planning, and management to deal with these extreme events. For example, if you want to assess the impact of a disaster, like after the disaster, if you want to assess the impact, then you need to apply the latest technology to do the disaster management effectively. You have to apply the science, technology, planning, and you need to have a proper management to deal with those disaster events. And the major focus of this particular disaster management is to prevent and minimize the losses. It could be either to the property or to the human lives. And this can be done in four ways. So the first one is the mitigation or prevention. The second one is preparedness. Third one is a response. And the fourth one is a recovery. So the mitigation refers to the act or actions taken to reduce or eliminate the long-term risks and impacts of a disaster. So for example, if you consider some countries, let's say, for instance, take an example as Japan. So everybody knows that the Japan is prone to the frequent earthquakes. So the designers or the people who are working in the construction industry in those countries, they are well aware about that, the earthquakes and the frequent magnitude, how the earthquakes occur in that country. So when they design for their infrastructure, they'll consider those earthquake magnitudes, and they'll design their buildings to resist or to withstand against that earthquake magnitude. So the mitigation means taking an action before the during the planning stage for future infrastructure or future construction activities. And the second one is the preparedness. So the preparedness means, for example, uh, let's take an example as a fire safety training. So if there is a fire event, they'll all like the security or authority will say like, use these they use these ways to exit when there is a fire incident. So likewise, all the fire industries or the hospitals or some laboratory people will conduct sometimes the mock drills for fire safety training and all. That means they are trying their people to exit whenever there is a fire accident happens. So that is the one example for the preparedness. The preparedness means making the people or that well trained to act accordingly whenever there is a disaster happens. That includes conducting some mock drills or creating emergency plans or stockpiling the resources. The third stage is a response. The response means the response means the action of people during a disaster. So when the disaster happens, how the government agencies or the people or the security agencies will respond and that to take the actions to save or to protect the properties and the lives of people. And the final stage is a recovery. So recovery will happen after the disaster. So this one we can call it as a post disaster activities. So for example, once the disaster happens, then what are the actions the people or the government will take to restore the normalcy of that particular area affected by the disaster? So that comes under the recovery. So for these phases, so the main focus of the today's lecture is how remote sensing and GIS will play a crucial role in these four phases of disaster management cycle. So the remote sensing has a unique capabilities, and that will be helpful for the designers or the for the designers or emergency planners or for the recovery team to plan their resources effectively. So remote sensing offers an accurate sorry so remote sensing and the GIS technologies provide an accurate and timely and actionable data which can form a framework for the planners and disaster managers to visualize the spatial data through the computer generated maps. So basically, I think everybody knows about what is the remote sensing and GIS, but in a few slides, we are going to discuss the basic principles of remote sensing and GIS. But before that, whenever someone says the remote sensing and GIS means mostly the data will be available in terms of a map. So when someone is looking at the maps, they can easily identify what are the resources available or what kind of features are available in that particular area. For example, if you look at the urban area, the people can simply say that yes, this particular area has buildings, roads, So that is easily identifiable area, easily identifiable features. And for example, if someone is looking at the rural areas or some water bodies and all, then they can easily identify the areas where the water bodies are located, or where areas where the agriculture areas are located, and where the residential areas are located and all. So that particular information is crucial for the planners and the disaster managers to take an action according to the magnitude of the disaster. And in the four stages of disaster management cycle, remote sensing has the different roles. For example, if you look into the mitigation strategy, so these remote sensing and GIS will help in identifying and mapping the hazard prone areas using a satellite images. First, so that means, for example, when you look at the satellite images, you can identify the flood prone areas or some geological formations such as a faulty lines or a landslide prone regions. And by looking at those areas, the disaster managers or the planners can give some suggestions to the urban infrastructure planners or infrastructure designers to consider or to design those infrastructure to withstand their facilities for all these disasters. And the main motive is here the remote sensing will help and will help to the implementation of effective measures to mitigate the impact. And when it comes to the preparedness, so in the preparedness, the remote sensing will help in identifying the areas which requires emergency attention. For example, when you have a real-time data with you, and if there's a flood event happening in those locations, then by just visualizing or by just looking at the map, then you can direct your emergency rescue team to that particular area. And the other thing is, for example, if there is a fire accident and the people in the control room got a call from the people got a call from the affected people saying that here is a fire accident happening in my areas, then what the control room will do is they will identify the nearby the fire department, and they'll pass the information to them so that they can reach to the area very quickly. So that's the another role of remote sensing and GIS in disaster management. So when you look at the maps, these maps will provide the relevant locations of the concerned departments for the disaster management, the agencies and the human resources persons, where they can act very quickly for to provide to do some rescue operations in a disaster prone areas. And these particular, when you have a map with you, that will simplify the strategy planning for security and the shelter providers. And when it comes to the response, so as I mentioned, the response means during a disaster. So the during a disaster, if you have a real-time data, then that provides a precise information about exact location of the disaster. And then based on, if you know the exact location of the disaster, then it is very easy uh, for the agencies or for the government officials to have an emergency operation or a rescue operation. And it helps in very quick or a rapid identification of disaster prone areas. And these maps, the remote sensing and GIS maps, can serve as a baseline or floor guide for evacuation routes. And finally, in the recovery stage, so after the disaster, if you have a satellite image, if you have a map with you with all the areas got affected by the disaster, and then if you mark each and every element, let's say in some area electric poles got vanished, and in some areas all the roads got vanished, and in some areas buildings got vanished. So when you have all those information with you in a map, then what you can do is you can track each and everyone, saying like in this particular area yes, electric pole work was done, and in this area the restoration work was done. And also you can update all the maps, and accordingly you can reallocate the resources for your effective recovery and all. So Apart from all this, the mitigation, response, preparedness, and recovery, remote sensing and GIS offers two more unique advantages for the disaster management, and those are called as disaster prediction and disaster assessment. So disaster assessment is somewhat related to the recovery. That means in the recovery you can track the effective implementation of your resources, and in the assessment that will helps the extent of damage caused by the disasters, and identifying the people affected, and analyzing the spatial patterns and disaster occurrences, and documenting all those impacts for the future planners. So that comes under the disaster assessment. And the next one is the disaster prediction. So the unique advantage of the remote sensing and the GIS is you can predict the future. So in the future, how are these going to affect? For example, if you consider uh, meteorological data, and if you do some trend analysis, that will give you an indication of like whether the particular event, for example, if you consider a rainfall and a rainfall extremes, so that particular one, and do the trend analysis, you can have some simple understanding on whether the rainfall and rainfall extremes are showing a decreasing trend or an increasing trend. If it is following an increasing trend, then that gives a basic understanding like that particular area is going to receive a more rainfall in the future, and the planners will act accordingly. So the similar way, the GIS offers unique capabilities in predicting all those events. But here the uniqueness of remote sensing and GIS is it provides the spatial visualization. So that is another advantage of use role of remote sensing and GIS in the disaster management. And now coming to the basics of remote sensing is an art of obtaining information about physical phenomena of an object or a feature on the Earth's surface measured from a distance without being in physical contact with the object of interest. For example, if you look at this particular image here, the features, this is the Earth's surface and this is a sensor. So if someone is interested in collecting the information about all the features on the Earth's surface, then he can collect the information about all those features from a distance. That could vary from 1 feet to the thousands of kilometers. And when they collect information without being physical contact, for example, even now also I'm in a remote area for you all guys, and you all guys are in a remote area for me. That means we are not in a physical contact, but we are exchanging some words. So this is also one kind of remote sensing. That means obtaining the information. So now you guys are getting the information about the role of remote sensing and DIS in a disaster management. This is a one kind of information. So this is basic example of remote sensing. So the remote sensing means it's an art of obtaining the information about the features or objects on the Earth's surface. So the features or objects means it could be anything. It could be a tree or an insect or a human body or a house or anything on the Earth's surface. And if you are getting information about those objects without being a physical contact, then we can call that as a remote sensing. And remote sensing will work on a principle of electromagnetic radiation, and here on the features on the Earth's surface have a unique response to the electromagnetic radiation. So when an electromagnetic radiation falls on those particular objects, each object will act differently to those materials based on to those electromagnetic radiations based on the material property, and that will reflect some amount of electromagnetic radiation, and this particular reflection will vary based on each material as I mentioned, and this reflected electromagnetic energy will be collected by the sensor mounted at whatever the height or the altitude by the observer. So for example, these altitudes also varies from 1 feet to the thousands of kilometers, and this electromagnetic energy will be recorded by the sensors. And as I mentioned, each object will respond uniquely to the electromagnetic radiation, and that typical response will be used to distinguish each objects. For example, the buildings will have one kind of response to the electromagnetic radiation, and the water will have one kind of response to the electromagnetic radiation, and all. And here is the electromagnetic radiation, and electromagnetic radiation consists of a range of rays, range varying from gamma rays all the way up to geomagnetic waves. And among all these, only some portion of electromagnetic radiation spectrum will be used for remote sensing and GIS purpose, which is mainly the visible region, which varies from zero point 0.4 micrometers to the 1 mm region, and which consists of visible and infrared region that is mainly used for data collection and analysis. And since the past 2 decades or 3 decades, because of advancements in the technology, now the people are using microwave remote sensing also for the data analysis. And apart from the microwave, there is another spectrum called radio frequency. The radio frequency will also be used in geostationary satellites for the satellite telephone communication or TV telecasting or the towers and all. And these are the electromagnetic spectrum ranges for each region of remote sensing and GIS, and they have different applications. So this particular one, 0.4 to 1 mm will be used in a passive remote sensing, and 1 mm to 1 meter will be used in an active remote sensing. And so, as I mentioned, the reflected electromagnetic radiation from the surface will be collected by a device which is mounted at somewhere in the atmosphere. But for that particular device, we have a technical name, and that is called the platform and the sensor. So the platform refers to the vehicle on which a remote sensing instrument is mounted to collect the data, and the sensor is a device that records the reflected electromagnetic radiation from the earth features. So in remote sensing, we will have three types of platforms. That is a spaceborne platform, next one is an aerial platform, and the third one is the ground-based platforms. And the spaceborne platforms means the satellite will be placed at a height of above 200 kilometers from the Earth's surface, and that will carry the sensor. And the major advantage of this particular satellite is it has a stable platform. That means the wind or any storms doesn't have any effect on it. And if a satellite is giving an image which will be geolocated, so and if you load that image into any of GIS or remote sensing processing softwares, then it will be located on the earth surface, and that represents the exact location. But the major drawback of this spaceborne remote sensing platforms is that they have a fixed temporal resolution. That means that particular satellite will revisit the same area on the Earth's surface after a certain amount of time. For example, if you look into the Landsat satellites, so that those satellites have 16 days temporal resolution. That means those satellites will visit the same area after 16 days. That means for one area, you have to wait for 16 days. And during these 16 days, if the disaster happens, then you will miss the whole data. That is the drawback of spaceborne remote sensing platforms. And the second one is the aerial remote sensing. So in the aerial remote sensing, the major carriers of the sensors are aircrafts, helicopters, the drones. So you can, and the altitude of these sensors will vary from few feet above the ground to the up to 1,000 meters or 2,000 meters. And the advantage of this particular aerial remote sensing is that You can acquire the data at any time of a day or for any event. For example, during a floods, if you want to collect the data, then you can simply fly an aircraft with a high resolution sensor, and then you can get the data of your interest. And here you can even change the resolution of the particular data. That means you can come very close to the ground and you can have a high resolution images, or if you increase the altitude, then you will have a low resolution. But the drawback of this particular platforms is that it has a high geometric errors, because for example, if you are traveling in an aeroplane, so whenever it passes through the clouds, then it will have some kind of jerks. So those jerks will form a geometric errors to this particular aerial images. And before using these aerial images for further analysis, we need to do a proper geometric corrections. And as I mentioned, these are low flying vehicles for collecting the data. So these are not very often. So these aerial remote sensing platforms are on specific purpose and for the specific area. And if someone wants to use, then it will be highly costly. So when you are using a data for the disaster management, you need to keep these also into your consideration. And the third one is ground-based the remote sensing. So the ground-based remote sensing means here a sensor will be placed in a vehicle, and vehicle will be driven around the area of interest. And the main purpose of this ground-based remote sensing is to calibrate the sensors which are going to be placed in satellites. So to do that, they need to have some basic information, and for that they basically use the ground-based remote sensing sensors. And the next one is the types of remote sensing based on the source of electromagnetic radiation. As I mentioned in my previous slides, the remote sensing will mainly work on the amount of electromagnetic radiation reflected from the earth objects. So based on depending on the source of electromagnetic radiation, remote sensing is classified into two types. One is the passive remote sensing and another one is the active remote sensing. So the passive remote sensing, the source of electromagnetic radiation is the sun. So when a sunlight when a sunlight comes from the sun and reflected from the earth surface, those reflected energy will be captured and that will be sent to the data units for further data processing. And the passive remote sensing will work in only the daytime, whereas in the active remote sensing, the satellite itself is the source of electromagnetic radiation. That means which can send the electromagnetic signals to the earth surface, and then it has the capability to collect the reflected electromagnetic energy. And next, there are there are different stages in remote sensing, and which includes the first one is emission of electromagnetic radiation from the source. So as I mentioned in my previous slide, so the source for electromagnetic radiation could be either sun as a natural electromagnetic source, or is an electromagnetic radiation or a spectrum which is located in the space, that is the satellite. So it could be any one of these. And the second one is the transmission of electromagnetic radiation from the source to the object. So during this process, all the transmitted energy will get into different scattering phenomena, because due to the presence of the particles or molecules in the atmosphere, all this transmitted energy will get absorption and the scattering. And when it interacts with the earth or objects on the surface, then there will be three phenomena. The first one is absorption, the transmission, and then reflection. So whatever the electromagnetic radiation reflected from the objects will send back to the satellite, and then satellites will collect or record that particular data either in the form of a photograph or in the form of some numbers. Basically, here all the satellites will record the data in the form of radiance values, but when you go for aerial surveys, then they will record the data in terms of photographs. That also depends on the kind of survey you are using. For example, if you are using a lidar, then the it will record the data in terms of points. And for the satellites, they basically record the data in terms of radians, and then that particular data will be sent back to the ground station, and from the ground station the data will be transferred into the processing center. And then once the data is processed, that means the radiance, as I mentioned, so the radiance data will be processed, sent to the processing center, and then from there they will be converting the data into either digital digital map or a hard copy map, and then those maps will be used. So for a user will get this particular data for the further analysis, so they won't get any of these data in any of these stages. So this is the only data available for the users for the further analysis. And the remote sensing, so as I mentioned, remote sensing is classified into two categories as a passive and active remote sensing. And in those, there are three kinds of satellites. The first one is a geostationary satellite. And in the geostationary satellites, the satellites are usually placed at a height of more than about 35,000 kilometers. And these satellites are fixed. Yeah, please look at this video. So the position of this satellite is fixed with respect to the position of the Earth. Yep. For example, if you look at this particular image, this is the geostationary satellite which is placed at a height of 35,000 kilometers from the Earth's surface. And excuse me, always this satellite will be looking at one particular area on the Earth's surface, and it take one complete day to revolve around the Earth's surface, because the rotation speed of this particular satellite will be equal to the Earth's surface, and its position is relatively fixed to the Earth's surface, so that it will have a continuous coverage for the same area over a period of time. And these satellites are mainly used for this communication purpose and some meteorological observations. And the next one is the polar orbiting satellites. And here, the polar orbiting satellite means the satellite will revolve from North Pole to the South Pole, and it takes now 90 minutes to complete one revolution around the Earth's surface from North Pole to the South Pole. And basically for these polar orbiting satellites, active remote sensing sensors will be used, because on the other side, for example, if you look at this particular Earth surface, in one side there is sunlight, and on the other side there won't be any sunlight. So to collect the data even during the night time, the sensor, like the satellite, should have the capability to send some electromagnetic radiation and receive some electromagnetic radiation. So for that purpose, basically the active remote sensing satellites will be used in this particular category. And the next one is the sun synchronous satellites. The sun synchronous satellites means, so these are also the type of a satellite which orbit from North Pole to the South Pole, but these satellites are designed in such a way that the path of the particular satellite will gradually shift, like their orbit gradually shifts to always stay aligned with the sunlight. For example, if you look at this particular region, so the satellite is adjusting its orbit so that it can align with the sunlight. So whenever there is a transition from a day to night time, then exactly at that location the satellite will align its orbit, and then it will collect the data continuously. And these kind of technology will be used in passive remote sensing passive sensors, because they don't have the capability to emit electromagnetic radiation, so they will collect the reflect, but they have the capability to collect the reflected electromagnetic radiation from the Earth's surface. So the sun synchronous satellites means those are basically some kind of passive sensors. And the next one is a resolution. So the resolution is the most important term in remote sensing, which defines all the applicability of remote sensing data for any application, not only for the disaster management, but for any application. It could be the land use land cover classification, or it could be the soil classification, or it could be the water bodies identification, or whatever it is. So the accuracy and analysis of the particular data will depends on resolution of a remote sensing image. So the resolution is defined as the minimum distance between two objects that can be distinguished in an image. For example, if you look at an image, and if you are able to distinguish two objects without any difficulty, then that will be called as a resolution. And in remote sensing, we have four types of resolutions. The first one is the spatial resolution. The spatial resolution means the measure of area or size of the smallest dimension on Earth's surface. For example, if you take some Landsat satellite, the smallest dimension that can make on Earth's surface is 30 meters. So this particular box is of a size of 30 meters by 30 meters. That means it has an area of 900 square meters. So that is the smallest dimension that a Landsat satellite can make on the Earth's surface. And if you look into some other satellites, they have a resolution of even in centimeters, but those are for the specialized applications. And the second one is the spectral resolution. As I mentioned, in electromagnetic spectrum, remote sensing uses the range of electromagnetic spectrum for its data collection. So that, and specifically visible region, which ranges from zero point 0.4 micrometers to 0.7 micrometers. And the spectral resolution means how that particular zero point 0.4 to 0.7 micrometers wavelength region was defined in a particular sensor. So in some sensors, those entire region will be defined as one sensor, and in some satellites, that particular one will be defined as 5 regions. For example, if you look into the passive sensors, so in passive sensors from zero point 0.4 to zero point 0.7, that will be defined from 3 to 7 bands. So if you consider Indian satellites, so the in Indian satellites, that will be defined as 4 bands: the blue, green, red, and the infrared. And if you consider the Landsat satellites, those region will be defined as 7 bands. That is a blue, green, red, near infrared, far infrared, and mid infrared. For example, yeah, this is the one. And if you look into the hyperspectral, excuse me. And if you look into the hyperspectral, this particular region will be divided into hundreds of bands. That means you may have some 400 to 500 regions in this particular electromagnetic spectrum region. And the next one is the radiometric resolution. The radiometric resolution means, for example, now everyone is familiar about these gray colors. So basically, when you look into an image, it will have the gray color ranging from 0 to some thousand colors, and that ranges from pure black to the pure white. So the radiometric resolution means how these pure black to pure white is divided. That means whether it has a 2-bit resolution or 1-bit resolution or a 10-bit resolution kind of. For example, if you look into the 1-bit means it will have only two colors, the black and the white. And if you look into the 2-bit resolution, it will have a three colors between a pure black and a pure white. And if you look into the 10-bit, it will have 1023 colors between a pure black and a pure white. And the next one is the temporal resolution. The temporal resolution means how often a satellite can visit the same area for a data collection. So some satellites will visit. So because as I mentioned, in a polar orbiting satellite, the satellite will take 90 minutes to complete one revolution around the Earth's surface. That doesn't mean that the satellite resolution, temporal resolution is 90 meters, but 90 minutes. So here the temporal resolution means the time taken for the satellite to visit the same area, on the Earth's surface again. So that one will be uh, that one will call it as a temporal resolution. And the next one is the spectral reflectance. So the spectral reflectance is the most important term in a remote sensing to distinguish different objects. So as I mentioned, the remote sensing has the capability, like the basic principle of remote sensing is distinguishing the different objects based on how much amount of electromagnetic radiation was reflected from those objects. So though based on that, they'll have some reflectance, spectral reflectance curves, and each object will have a unique spectral reflectance curve, and based on that they will classify those objects. And for example, if you look into the water, that will have a spectral reflectance of ranging from 5 to 70 based on water quality. And for example, if you look into the grass, that has a spectral reflectance of 25%. That means the 25% of electromagnetic radiation will be reflected from the grass. And if you look into the vegetation, based on the vegetation health also, these particular spectral reflectance curves will change. So based on that, the user or the remote sensing operator, or they can classify the data, and that can be used for further analysis. And these are the some satellite images. So these are the satellite images of a Landsat file. As I mentioned, so basically the passive remote sensing will work in a visible spectrum, and they divided the entire visible spectrum into the 5 bands. So that 5 bands have a different informations, and the first one, the band one, that is a blue. Sorry, I couldn't remember those names. So the band one is ranging from 0.45 to 0.52, and then it varies. So here the main advantage is when you are trying to do the analysis, you need to combine all these images, which is called image stacking, I think, and then you have to do for further analysis. And the use of these particular images also will depend on the type of application. For example, if you are mainly interested in identifying the water bodies, then you can go for infrared region where the water will absorb a complete electromagnetic radiation and you'll have a reflectance of 0. You don't get any reflectance from the water bodies. And if you use the infrared region, then you can identify those water bodies very easily. And for the vegetation also, the infrared region is the most effective because that's the region where vegetation will have a maximum reflectance. And the next one is the geographical information, GIS. So GIS is an acronym of Geographical Information Systems, and it is an integrated tool for which is capable of mapping, analyzing, manipulating, and storing the geographical data in order to provide solutions to the real world problems, and in helping the planners or the designers to plan for future infrastructure. And the GIS consists of 5 components, which is a hardware, the software, a data, methods, and the people. And this is a GIS framework, which includes which starts from input and ends at output. And in the between, it has different stages. The first one is data collection, input, and correction, which includes, like for data collection, as I mentioned, from the remote sensing data, you will have an hard copy or the soft copy maps. And in India, the Survey of India is the main source for all of us to have a topo sheets or Survey of India maps. And they'll provide those maps either in a soft copy format or in a hard copy format. And when you want to use or analyze that particular data, then you need to convert that particular data into some digitalization format. So the digitalization means having a soft copy in your computer is not the digitalization in the GIS framework. In the GIS framework, digitalization means converting that particular data into some editable data formats in the GIS framework. And that is one of the steps in input data. The next one is storage and data retrieval. So it includes the lot of steps, that is format conversion. For example, if you have an AutoCAD files, then you need to convert that data into the GIS format, and then data reduction. So in GIS, you will have a huge amount of data, and all the time you may not be working on the same data. So that means you need to remove or delete the data which you don't like. And error detection and editing. So in your data, you will have some errors and you need to adjust those errors. And then some cases, you will have a different data sets and you have to merge all of them into the one data set. And then edge matching at the edges, GIS data will have some errors. You need to do some kind of edge matching, and then you need to do some interpolation or interpretation of a data and all. And the next one is the manipulation. So once you have a data with you, and once the data is corrected for all the errors, once you eliminate all the errors and all, the next what you can do is you can do some manipulation and analysis. So I'll just give a brief example of spatial operations. So I think nowadays everyone is using a Google Maps to navigate from one location to another location. And when you start a Google Maps, that will show, like Google Maps will give a minimum of 2 to 3 options from your starting location to the ending location, and they'll even mention the time also. So that is that one we call it as a shortest path analysis in a GIS framework. And in the GIS, first it will identify all the possible routes from starting location to the ending location, and then it will calculate the distance and the time taken to travel that particular distance, and the number of turns and the number of junctions are there in the particular route. And then it will calculate the time for how much time it will take to turn all those turns, and then how much time it will take to pass each signal. If there is a signal or a junction, then it will even measure how much time it will take to pass all of those junctions and all, and finally it will provide you the shortest path. So that is one of the analysis of GIS framework. And once you have all those data sets, finally you can send the data as map or as a soft copy or a hard copy, or you can send some statistical reports, some maps and all to the end user. And in GIS, we have 2 types of data sets. One is a spatial data. The spatial data means it's a kind of information which will help you to identify the locations of the features or the boundaries on the Earth surface. And it has the 2 types of data structures. One is a vector data and another one is a raster data. So in a vector data, the features on Earth surface will be represented as the points, lines, and the polygons. And in the raster data, the real world features will be represented as a regular grid of cells. And the non-spatial data is, if the data is not related to the location on the Earth surface, but it provides additional information to your spatial data, then we call that as non-spatial data. And these are some representations of how the vector data will how a vector data can be used for representing a feature on the edge surface, and how raster data can be used to represent a feature on the edge surface. For example, if you want to represent a small entity, then in the vector data you can represent that as a point, and in raster it will be a cell. And if if you want to represent a road network, a linear feature, then you can simply use a line. But in raster it should be a number of cells. And if you want to represent a water body or an area, then you can have a polygon in the vector data, but in raster data it's a group of cells. So this is the some basics about remote sensing and GIS. And with these basics, finally, the output of the remote sensing and GIS, and after all these analysis, the output should be a map, which should contain all the information required for end user. So the purpose can vary. Like for example, if someone is interested in road designs, then it will have only the road maps. And if someone is interested in forest management, then it will have only the information about the agriculture, the greenery. And if someone interested about the residential areas or the population, will have information about only those residential areas and all. And with this basic information, so for whatever we have covered for the remote sensing and GIS, and now I would like to give some examples or case studies where I worked effectively to have some data for the disaster management planners and all. And one among those is the use of spatial data to forecast floods. As I mentioned, floods is the one of the very frequently happening disaster in India. And if you have flood forecasting information, then that will help the emergency planners to plan their response and recovery operations. So the data we used for to have a forecast to forecast the floods was the observed rainfall data, observed temperature data, and hydrologic data. So the hydrologic data means the flow data, the river flow values, and then forecasted rainfall and the temperature, digital elevation model, the land use, land cover, and the soil data. And this particular work was done over the Nagaval and Vamshadhara basins. And here we have two gauge stations, one in each basin, like the Kasinagar in Vamshadhara basin for flow data, like the river flow data, and the Srikakulam in Nagavali basin. So the data we collected at these two gauge stations, I'm calling it as a hydrologic data. And then these are the digital elevation model. This is the digital elevation model of both the basins, and this is the land use, land cover map of both the basins. And this is the soil map of both the basins. And this particular basin contains almost the predominantly four soils. And once I have all these data sets, and this is the spatial representation of rainfall data which I used to forecast the floods. And so to forecast the floods, what we used was, first we used the SWAT model, that is a soil and water assessment tool, to convert this rainfall data into the hydrologic data. So in the initial stages, we integrated all the land use, land cover map, the soil data, the digital elevation model to form these subbasins. These are the different subbasins in each river basin. And once we have all these subbasins, then we gave a rainfall and the temperature data as an input. And that particular data was helped us to convert the rainfall, like based on the given rainfall on the temperature data, the model gave us an the flow estimates at these two gauge stations. Of course, so the model has the capability to give the flow estimates for each subbasin individually, but as I mentioned, we don't have any data to validate our model in any of these locations except at one location in each basin. So we collected all the flow estimates provided by the model at these two known locations, and then we performed validation, calibration, and validation. And these are the calibration maps in the Nagavali Basin at Srikakulam Gauge Station, and these are our calibration coefficients. And we did all these analysis for daily data, and for the daily data, these are the very good statistics, like having an R square of around 0.6 is a very good statistic. And if you take a monthly or annual data sets, then these statistics should be higher. For example, for monthly, it should be something around about 7.5, and for annual, it should be something about uh, point above point 0.9. Then only those will be considered as a good. But when you are doing this calibration for the daily data, then these will be considered as a good estimates of data. So we did a calibration and validation, and we found that the model has the model is working pretty well for the observed data. This is for the Nagavali Basin at Srikakulam Gauge Station, and then we did the similar analysis for the Vamsadhara Basin at Kasinagar Gauge Station, and we found a little bit better statistics in Vamsadhara Basin compared to the Nagavali Basin. And once we have all these flow measurements, then what we did was we used an hydraulic model. So the earlier the SWAT, the model we used to convert to rainfall to the flow data was hydrologic model. And now once we converted the rainfall into the flow values, then we used an hydraulic model which has the capability to convert the flow values into the flood inundation maps. So here we used a HACROS model to develop or to predict or to forecast the flood inundation maps in both the basins. And this is the effective area we used for the flood forecasting. And to forecast the floods, we marked this, and we divided this entire area into 100 meters by 100 meter mesh. And then we used these points, so point here, here, and this one as an upstream conditions, and we gave the flow data at these locations. And as I mentioned, as we don't have any validation at these locations, so we validated the data at this particular location, and based on that, assuming that the entire basin will have same accuracy, we took the flow values at these locations and gave that as an input to the hydrologic model. And similarly for the Nagavali basin also, we gave flow data as input at these two locations and gave that as input to the basin. And once after giving all the data as an input, when we simulate the data, these are the flood inundation maps for the past events. So we considered almost 16 events in the Nagavali basin and 16 events in the Vamsadhara basin, and we were able to generate the flood inundation maps for each of these events. And then these are the flood inundation maps for the Vamsadhara basin. So far, whatever the model we were developed, that model was working pretty well for pretty good for the past events. And now, based on understanding that this model is working for the past events, then we started working on future events. So for the future events, as I mentioned in the data used, we used forecasted rainfall and the temperature data to have a future flow data, and that one was used to have a future flood information about the future flood events in this particular event basins. And for that, we took one flood a cyclone as a reference, that is a Titli cyclone, which caused severe flood in this particular Vamsadhara basin. And this was the only data as available for us to have to validate our model. So this is the actual flood inundation map. Actual area got flooded during the Titli cyclone, and this data we got from NRSC. They provided this data in their Bhuvan website. And then we used different data sets. The first one is the gauge data we got from CWC, Central Water Commission. And then This is the flood inundation map generated by using that gauge data. And then we used rainfall data provided by the Indian Meteorological Department to convert to generate the flow data, and we used that flow data as input for the hydrologic model to generate a flood inundation maps. And finally, to forecast the floods, we used rainfall from global forecasting system, and we considered, because the global forecasting system has the capability to provide the rainfall forecast for 16 days. Like from today to the next 16 days, it has the capability to provide rainfall forecast, and we did a proper validation and bias correction, and we did all the statistical analysis on those GFS data sets, and we found that the rainfall forecast for the next 2 days, or not the 2 days, 5 days, for the next 5 days are more accurate. And we used those five days of rainfall data, and when we used those 5 days of rainfall data to generate these flood inundation maps and all, and later we found that only 2 days of the flow data is good for generating these flood inundation maps. And finally, we came to the conclusion that the model we developed has the capability to provide flood warnings at least 48 hours in advance to the event. And then we did some kind of a statistical analysis saying like how much percentage of area is intersected with respect to the actual flood inundation area and the forecasted areas. And when we looked at that, when we used the hydrologic data provided by the CWC, the percentage of area was in 75% of area was intersected. That means it has an accuracy of 75%. And when we used the IMD rainfall data, it has an 86% accuracy. And when we used the GFS data, it has an accuracy of 76% for 1 day forecast and 75% for 1 day forecast. So after doing all these analysis, we gave a conclusion that the more developed model has the capability to provide the flood inundation maps with a 75% accuracy in 2 days advance. And once we have all these data, so it's not about how much data you have with you, and it's all about how you are communicating this particular data, or how you are transferring this particular data to the end user. That will make a significant impact, or that will help the disaster managers or the rescue operators or any other agencies to act accordingly. So to do that, sorry, before that, so based on all these flood inundation maps, then we developed a vulnerability map, because now we know the flood inundation maps, because we consider all the flood events from all the way from 1990 to 2018. And then we did all the flood inundation maps analysis and all, and based on all these past events, then we did some vulnerability assessment. That means how many villages, or what are the villages or the areas that are highly vulnerable to the floods, and these are the areas or the villages which are highly vulnerable to the floods in both the Nagawali and Vansadhara basins. And then we gave to a statistical conclusion that almost an average area of 220 square kilometers, and at least 1 lakh people in the 115 villages in the Nagawali basin are prone to the floods. And if there is any flood alert, like if the in future if there is any flood alert is going to give in those particular in Nagawali basin, then these are the first 115 villages needs to be given. And then the next one is around 270 square kilometers, and almost 135 villages in the Vansadhara basin are prone to the floods. So as I mentioned, it's not about how accurate we have a data. So like even if you have a high accuracy data with you, and if you're not communicating that data to the concerned authorities and to the people who are vulnerable to these disasters, then all the data is of no use. So to communicate this particular data effectively to the people and to the communication concerned authorities and all, we developed a WebGIS based flood visualization and a distribution system. And of course, this is not still going for some modifications and all. So in this particular system, what will happen is, obviously for every 24 hours, these flood inundation maps will get updated in the basins, and with respect to the depth information also. For example, it has a depth of from 1 to 6 meters, and it will give you the information about how much depth is going to happen, like the flood and all, and the further information. And this information can be used by the concerned authorities and the people to plan for rescue operations and all. This is the one application. And the another application is the another disaster in India. It's I won't say it's a disaster, it's a frequent happening incident, that is the tropical cyclones. So starting from southwest monsoon to the all the way up to the end of northeast monsoon, either a Bay of Bengal or Arabian Sea will experience some the cyclones. And if you have a prior information about its track and intensity of those tropical cyclones, then the government authorities or concerned authorities and rescue operators can plan their activities accordingly. And for that, I considered almost 10 tropical cyclones to have a proper prediction system and all. And this is the domain I considered for predicting all those tropical cyclones. And I used weather research and forecasting model to forecast all these tropical cyclones. And here is the track, the predicted track for cyclone Hudud, for the cyclone Hudud. And here I used mean sea level pressure to predict the track of a tropical cyclone. And then we used a maximum sustained wind to predict the intensity of a tropical cyclone. And finally, we even predicted the total accumulated rainfall in millimeters for that particular tropical cyclone. And then we did some statistical analysis on how accurate the predicted rainfall in response to the observed rainfall. And we considered Vamsadhara Basin just to validate our estimates. And from the observed IMD records, the basin received a rainfall of 148 millimeters. And then when we compared that with the prediction, our WRF model, it provided nearly close estimates, that is around 200 to 220 millimeters. And then, as I mentioned, we used global forecasting system rainfall data also. So we even compared the forecasted rainfall with that particular data sets. And then that also showed a good agreement with the estimated rainfall. And the another case study is analysis of Patel Milmet Dam burst in Kenya. So this is the post-event analysis. So the previous two examples which I showed, those are the pre-event, like the future planning events, and this one is the post-analysis event, which I worked with one of my senior. And here there was a dam burst happened in Kenya on May 9th, 2018, because of heavy rainfall in the upstream areas. And because of that particular dam burst, it caused almost it took a life of 48 people, and including the large scale infrastructure and agriculture damage in the downstream areas. And to do this particular analysis, so this is the location of that particular location map, and here is the dam. It's a small dam, not a dam constructed by the government authorities and all. It was a dam constructed by the local farmer for his particular agriculture purpose and all. He constructed dam for that particular purpose, and it's a small one. That's why he kept his name. And so when the dam burst was happened, because that is some remote area, and we don't have any access to their records of how much rainfall was happened and all. So here we did this analysis completely depending on the satellite or remote sensing and GIS technologies. So the some of the satellites, some satellites are there. They provide really good estimates of the precipitation. One among them are TRMM, GPM, and GS map. Those are the satellites which provides the precipitation data. And here we took satellite data, GPM precipitation data, and as well as some satellite observations. So luckily during that particular time we were able to have the two satellite observations. One is the Sentinel-1 and another one is the Sentinel-2. So we took both the Sentinel-1 and Sentinel-2 data sets for the analysis, and then we even collected, these are the Sentinel images for both the before and after the event. So the top, the image A represents the Sentinel image before, after the dam burst, and this particular one represents before the dam burst. And then by integrating all these data, we came up with the area affected by the floods. So this area was extracted based on the soil moisture information, and we took a relative soil moisture from its corresponding areas to this particular area, and we captured the soil moisture information, and the areas having high soil moisture are basically affected by the floods. And then from this analysis we came to know that almost 40 hectares of agricultural land fields got damaged, and 1 kilometer of length of road network also got damaged. So these are some examples of where you can use remote sensing and GIS for effective analysis. But as I showed you in my previous slides, remote sensing and GIS can be used for quick visualization of the magnitude of all the disasters that happen and all. And this is all I have for today's presentation, and thank you. Sorry.
I request the participants to have a few question and answer sessions. If you have any questions, please ask to the resource person.
Class అయిపోయిందా?
Uh, uh, Yogi, can you hear me?
Yes, sir.
Yeah. I welcome all the participants for this question and answer session. If you have any queries regarding this session, you can ask Dr. Rao. He is available to answer all your questions.
Yeah, thank you, Raghubabu sir. So there is one question in a chat box. So Arvind, the QGIS is the most used open source software, and which is approved across the world, and it has all the features, and I would say little bit advanced features than commercial software. So you guys can have QGIS for your normal operations, and which is approved across the world, not only by AICTE, but it is approved across the world.
Is there any questions from the participants? Right. Any AI tool, sir? There is a question from Sharma. Any AI tool integration for GIS analysis?
Well, sir, as I mentioned just now, the QGIS, it has like both all the commercial softwares has the programming capabilities like RGS or QGIS, and all they have their own windows where you can use the Python programming, and you can integrate any technology, like it could be either artificial intelligence or machine learning or deep learning. It's a application specific, so for those softwares doesn't provide default AI integration. But if you are interested, you can try their terminals. Like they even provide some basic examples of code, and you can work with them, and then if you want, you can integrate your own AI tools for your specific application.
Sir, there is another question from Nagarajan. How does the integration of GIS with IoT help?
Sir, for real-time environmental monitoring, so basically for example, if you look into the cyclone warnings, they'll provide updates in uh, every half an hour, or they will provide hourly updates, and it's all depends on how your GIS data is. For example, if you look into some satellites, what we call it, the geostationary satellites, those satellites have the capability to provide data at every uh, like I didn't remember exactly. This discussion was happened somewhere back in 2019 when I was working at a space application center at Ahmedabad. The scientist at space application center told to me like the satellites has the capability to provide data at minutes interval, but during these extreme events they will alter that particular satellite to have a data at sub-minute interval, maybe around every 30 seconds and all, and they will process the data in a real time, and they will provide the data in real time. And then yes, there is a capability for you can integrate your IoT also for that.
Yeah. Sir, there is another question from Nagarajan MG. How is augmented reality integrated with GIS, and what are its applications in fields like tourism, architecture, and emergency response?
Well, sir, it's a good question, but to be honest, I haven't worked in augmented reality, but I can look into some of those documents, and I can share with either Siddhar sir or Raghubabu sir, and they can forward those documents with you. Sorry for that.
Sure, sure, sir. Sir, could you please provide your mail ID with the participants in future if they
Yeah,
need to
sure,
communicate you? Could you please
sure. I'm
specify?
providing my mail ID in chat box.
I request the participants, if you have any questions regarding remote sensing and JS, Dr. Rag is available in this mail. You can contact him. Right. With this, I'm going to conclude this session. On behalf of organizing committee of the 6 days online faculty development program sponsored by AICTE, I extend our heartfelt thanks to Dr. Rao for your enlightening session on remote sensing. I'm very much thankful to you, sir, for taking the time to be with us and for your invaluable guidance. We truly inspired by your contribution, which played a significant role in the success of our program. Thank you once again, sir. We hope to have the privilege of working with you again in the future. Thank you. Thank you very
Thank you,
much.
sir.
Right. Thank you very much, sir.
Thank you.
Right. Yogi.
Yeah.
Sir,
Raghu?
Sir, are you there? Yeah. Sir,
Yeah,
over to you.
Raghu. Yeah, sir has joined, no?
Just now,
Yeah.
Venkat sir session has been completed, sir.
Yeah, I was there. Like, okay. So now, my dear participants, good evening once again. I hope you had a good session. Now, I'd like to introduce our next speaker, R.K. Jai Gopal Garu. So, R.K. Jai Gopal Garu is having vast experience in bridge engineering. He's ME in structural engineering. He's having 44 years experience. He has awarded IRC medal for rehabilitation of bridge across Vrishaba on Magadi Road, Bangalore. Is the chairman technical advisory committee, Bruhat Bangalore Mahanagara Palika. He has been awarded IRC medal for rehabilitation of bridges across Vrishaba on Magadi Road, Bangalore. Is a member bridge committee of PIRAC, Permanent International Association of Road Congress, Paris. Is a member Bridge Specifications and Standards Apex Committee. He is a member in so many technical committees. He is a chairman Karnataka Center, IIB, that is the Indian Institute of Bridge Engineering, which is very prominent, like it's growing like anything. He's bridge and structure international airport, railways, space, etc. And overseas experience is expert advice for runway construction of ocean bed by dredged materials and many geotechnical works. He is also a member of IRC, Indian Institute of Engineers, American Concrete Institute, American Society for Testing and Materials, Indian Concrete Institute, and INGI Delhi. Apart from that, he presented 2 papers on turnkey on bridges. And coming to his brief work experience, he's having so much experience in bridges, which almost nearly 27 projects he was involved in bridge engineering. He's having vast experience in bridge engineering. And take
Hello.
Sir, kindly provide the feedback link.
Yogi, are you there?
Yes, sir.
Jai Gopal sir available?
Yes, sir. Jai Gopal sir is there, I think.
Yeah, I am
Sir,
here.
Sir,
Sir,
sir.
can you hear me, sir?
Yeah, I can hear you.
Sir, could you please share your screen, sir?
Yeah. 1 minute.
Actually, Professor Sridhar sir connection is not well, it seems.
I think he is sharing. If he is sharing, I will not be able to share.
Yes, sir. Yes, sir. Yogi, could you please allow Professor Jai Gopal to share his screen?
Sir, Jai Gopal sir, you can share your screen, sir. It is permitted to share the screen, sir. It is all.
Share. Okay. Share. Okay. Can you see now?
Yes,
Yes,
sir.
sir.
It's working.
It's working. Oh, fantastic.
Sir, could you please hit on presentation mode?
Yes.
It will be right corner, sir. It will be at right corner. Down.
Down, sir.
Behind the zoom button, sir.
Behind the zoom button.
Sir, or else press F5, sir. F5.
Or else hit F5, sir. Function key F5.
Now we can see.
No, sir.
Uh,
Sir, at corner there is a zoom button, right?
Down corner, sir.
yeah, this one, I think.
Behind the zoom button, there is an icon.
Sir, or else on the top you can see a menu tab called slideshow.
Menu.
Slideshow, sir.
Yeah, after animations, there is slideshow tab in menu button, sir.
1 minute. Yeah.
Yeah.
ಇಲ್ಲಿದೆ.
Or else please hit F5 button. F5 button on your keyboard.
Share. Window. JNT. Share. Correct, ಅಲ್ಲ? Ignore. Hide. Okay. ಇದೆ ಸ್ಲೈಡ್ ಶೋ ಅಂತ ಇದೆ.
Sir, come to
there
the down corner, sir.
Yeah. Now, can you see now?
Yes, sir. Could you please slide the slides? Could you please come to second slide?
Full screen. Open picture. Settings. Next up. ಇದೆಯಲ್ಲ ವಿಂಡೋ ಈಗ ಬರ್ತಾರೆ. ಓಕೆ ಸ್ಲೈಡ್ ಶೋ. ಕ್ಯಾನ್ ಯು ಸಿ ನೌ?
No, sir.
No, sir.
Please share your screen, sir.
Yeah, 1 second. Yeah. ಇಲ್ಲಿ ಇದು ಶೇರ್.
Sir, if you allow, I will share my screen and I will let you know, sir, where is
Please,
that
please. Please. That will be very good. What shall I do now?
Sir, I will show my screen.
Yeah.
I will let you know where that the button is, sir.
Yeah. Please, please.
Sir, can you see my my screen?
Yeah. I can see.
Yeah, here, sir. Here there is a tab, right?
Yeah.
This
Yeah.
one.
I know.
This one, sir.
Yeah.
This one, sir. Sir, can you see this one?
Yeah. I can see that.
This one, sir.
No, that I will have to make it is it?
We need to hit this button.
Okay.
This
Okay.
button. I'm stop sharing. Okay. Now please share your screen now, sir.
Yeah. ಇದೆಲ್ಲ ಸ್ಟಾಪ್ ಶೇರಿಂಗ್ ಯಾವುದು ಇದಲ್ಲ
ಬೇರೆ PPT ಓಪನ್ ಆಗಿದೆ ಸರ್.
ಬೇರೆ ಬಿಟ್ಟು ಯಾವುದು ಓಪನ್ ಆಗಿಲ್ಲ ಇದು ಓಪನ್ ಮಾಡ್ಬೇಕಾ
ಕ್ಲೋಸ್ ಮಾಡಿ.
Yeah, now hit that button, sir.
ಕ್ಲೋಸ್ ಮಾಡಿ. ಇವಾಗ
ಯಾವುದು ಇವಾಗ ಶೇರ್ ಮಾಡಿ
ಶೇರ್ ಮಾಡಿ.
ಓಕೆ ವಿಂಡೋ
ಸರ್ ಇಲ್ಲಿ ಬನ್ನಿ ಸರ್, ವಾಪಸ್ ಇದು ಮಿನಿಮೈಸ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸರ್.
ಹಾಂ
Dear participants, I have shared the feedback link for session 7. Meanwhile, you can fill that form.
ಇದಾ
ಹಾಂ ಸರ್.
Sir, can I help you?
Yeah, one my staff is also here.
Yeah, now it's good, sir. Just hit on that button. Just come to that. Just that button. Click that button, sir. Wait,
F5 button.
Sir, I will Shishna sir.
Are there? Could you place that presentation to us?
Yeah, that's the thing I'm thinking now. I will just transfer it off.
Yeah. Please mail to Sridhar sir. Mail, sir.
Yeah. 1 minute.
Yogi, are you there?
Yes, sir, I am there.
Please confirm whether you received that mail or not.
Well, sir.
ಇದು ಎಲ್ಲಿದೆ ಇದು ನೆಟ್ ಅವ್ರಿಗೆ ಹಾಕೋಣ ಇದೆಲ್ಲ ಕರೆಕ್ಟೇ ಇದು ಬಟ್ ಎಲ್ಲ ಇದು ಎಲ್ಲಿದೆ ಇದು ಅಲ್ಲ ಇದು ನೆಟ್ ಹಾಕ್ಬೇಕಲ್ಲ ಅಲ್ಲ ಮಮ್ಮಿ ಎಲ್ಲಿ ಇದೆ ಅದು ವಾಪಸ್ ಹಾಕ್ಬೋದು ಬಟ್ ಇದು ಎಲ್ಲಿದೆ ಇದೆಲ್ಲಿದೆ
Sir, F5 will also work, sir. Function F5 key.
Yeah.
ಇದಲ್ಲ
Kindly use the F5 key, sir.
Please just hit F5 button, sir.
Sir, there might be problem with PowerPoint, sir. We can see that.
One second, I will just transfer it to Shashidhar sir.
Sure. Yeah, sir. It might be better.
First mail to answer Shishidhar copy ಮಾಡ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ back side. ಹಾಂ ಸರ್.
ಇಲ್ಲಿದೆ
ಹಾಂ ಸರ್.
ನೋಡಿ ಅಟ್ಯಾಚ್
ಫಾರ್ವರ್ಡ್ ಸರ್, ಫಾರ್ವರ್ಡ್.
ಇದೆ
Yes.
ಇಲ್ಲ ಇದನ್ನ ಕಾಪಿ ಮಾಡಿ ಅವ್ರಿಗೆ ಹಾಕ್ಬೇಕು ರಿಟರ್ನ್.
ಮೇಲ್ ಟೈಪ್ ಮಾಡಿ ಕ್ಲೋಸ್ ಮಾಡಿ ಸರ್. ಇದು ಕ್ಲಿಕ್ ಮಾಡಿ ಜಸ್ಟ್ ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಸರ್.
ಓಕೆ,
ಹಾಂ ಸರ್.
ಅಟ್ಯಾಚ್ ಮಾಡಿ.
ಇಲ್ಲ ಸರ್, ಅಟ್ಯಾಚ್ಮೆಂಟ್.
ಓಕೆ,
ಅಟ್ಯಾಚ್ ನಾವು ಕಂಪ್ಯೂಟರ್ ಸರ್.
ಓಕೆ,
ಮೇಲ್ ಡೆಸ್ಕ್ಟಾಪ್. ಹಾಂ ಸರ್, ಇದು ಡೆಸ್ಕ್ಟಾಪ್.
ಓಕೆ,
क्या बने सर? ये क्या बने सर? JM2 ಇಲ್ಲ ಇಲ್ಲಿ. ಹಾಂ ಸರ್.
ಇದಾ?
ಹಾಂ ಸರ್.
ಓಕೆ,
ಇಲ್ಲಿ ಸರ್ क्या बने सर? ಅದು ಸಿಗಬೇಕಾ ಕ್ಲಿಕ್ ಮಾಡಬೇಕು. ಮೇಲ್ ಇದು ಡಿಲೀಟ್ ಮಾಡಿ ಸರ್. ಇದು ಇಲ್ಲಿ ಕಾಣ್ತದೆ ಸರ್. ಹಾಂ ಸರ್, ಇದು ಓಪನ್ ಮಾಡಿ ಸರ್.
ಓಪನ್.
ಹಾಂ ಸರ್. ಫೈಲ್ ಜಾಸ್ತಿ ಇದೆ ಸರ್.
ಫೈಲ್ ಜಾಸ್ತಿ ಇದೆಯಲ್ಲ. ಹೇಳ್ರಿ.
ಹಲೋ, ಅದು PPTನ ಶೇರ್ ಮಾಡಬೇಕಿತ್ತು, ಮೇಲ್ ಮಾಡಬೇಕಿತ್ತು. ಹಾಂ, ಅದು 25 ಮೇಲ್ ಇದೆ, ಅದು ಏನು ಮಾಡೋದು? 25 MB ಅಂತ ಬರ್ತಾ ಇದೆ. ಹಾಂ, ಟ್ರಾನ್ಸ್ಫರ್.
ನಾವೇ ಶೇರ್ ಮಾಡೋದ್ರಿ.
ಹಾಂ, ಶೇರ್ ಮಾಡಬೇಕಿತ್ತು, ನಾನು ಮೇಲ್ ಮಾಡೋದು ಅದಕ್ಕೆ. ಅಟ್ಲೀಸ್ಟ್ ಶೇರ್ ಮಾಡೋದಂದ್ರೆ ಹೇಳಿ, ಅದು ಶೇರ್ ಆಗ್ತಾ ಇಲ್ಲ ಅದಕ್ಕೆ. ಅದೇನೋ ಸ್ಲೈಡ್ ಕ್ಲಿಕ್ ಆಗ್ತಾ ಇಲ್ಲ PPT ಮೇಲೆ. ಒಂದು ಸೆಕೆಂಡ್ ಪ್ರೊಸೀಜರ್ ಹೇಳಿ, ನಾನು ಮಾಡ್ತೀನಿ. ಶೇರ್ ಮಾಡಬೇಕಂತಿದೆ ಸರ್ ಇವಾಗ ಅದಕ್ಕೆ. ಹಾಂ ಹಾಂ, ಶೇರ್ ಆಯಿತು. ಹಾಂ ಸರ್. ಹಾಂ ಹಾಂ, ವಿಂಡೋ.
ಹೌದು.
Yogi,
Sir,
can't you operate Jai Gopal's screen from?
no, sir. It takes some more time. Let SR share the PPT, sir. That's not an issue. So wait for a few more minutes.
Okay.
Sir, if there is a problem with that presentation mode, you can continue with the present view, sir.
So if you don't mind, please proceed with this only, sir. We will zoom our screens.
Jai Gopal, sir. Jai Gopal, sir.
Okay. Okay. Can you hear now?
Yes, sir. Yes, sir.
Yes, sir. One minute.
Yes, sir.
I'm
Yes,
just
sir.
taking help. 1 minute. Vinita. Yeah, they are. Can you see the screen now?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Vinita, tell me. Yes, they can see the screen now. Okay. Here. Huh? Can you see now?
Yes, sir. Yes, sir.
Can you see? I'm shifting this one slide to 1, 2, 3. Now you can see. Now you can see the slides
Yes, sir. Visible.
visible.
Yes, sir.
Second,
Yeah,
third,
sir.
fourth. Now
Perfect,
it's
perfect.
visible.
Sir, could you please press on F?
Is it visible?
Sir,
Yeah,
it's
sir.
visible like as previous only, sir. Not
Sir,
as
it is visible but not moving from slide 1 to slide 2.
Now,
Now also, sir, that's why you need to, sir, there is a icon there from beginning. Please hit on it, sir. From beginning.
Vinita.
Sir Jai Gopal, sir, or else please save the file as PDF and you can present it in the PDF mode, sir.
Sir, in top right corner, there is an icon from beginning. From beginning. In
Sir, left corner, sir.
from beginning, from current slide like that, na sir.
From beginning, yeah. Correct.
Hit on it, sir.
Now you can see?
No, sir. After hitting, you need to wait for a while, sir.
Okay.
Just hit on from beginning and wait, sir. Or else save your PPT in PDF format, sir. It will be more easy. Now move to next slide, sir. Just click on slide number, sir. Then it will be easy.
Jai Gopal, sir, please save your PPT file as PDF, sir, if possible. That could be better.
No. Yeah. Now open that PDF file, sir.
ಬಿಟ್ಟಿಲ್ಲ
PDF, sir.
PDF ಅಲ್ಲ ಇದು
PDF, sir.
ಇದು ಮತ್ತೆ ಅಲ್ಲಿ ಶೇರ್ ಮಾಡೋದು ಶೇರ್ ಆಗ್ತಾ ಇದೆಯಾ
Open ಮಾಡಿ.
ಮತ್ತೆ ಹಂಗೆ ಹೋಗ್ತಾ ಇದೆ
Stop sharing ಮಾಡಿ.
ವಿಂಡೋಸ್ ಹಾಕಿ ಅದೇ ಇದೆಯಾ
ಹಾಂ ಸರ್ PDF, ಸರ್.
PDF ಇದು ಓಕೆ ವಾಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ಹಿಯರ್ ಐ ಡೋಂಟ್ ನೋ
ಸರ್ ಈಗ ವಿಸಿಬಲ್ ಇದೆ ಸರ್, ನೀವು ಮೇಲೆ ಕೆಳಗಡೆ ಒಂದ್ಸತಿ ಸ್ಕ್ರಾಲ್ ಮಾಡಿ.
Sir, it's good now, sir. Just scroll the page and continue, sir. Yeah, it's good now, sir.
It is okay?
Yeah, it's okay, sir. It's okay.
Okay. You can see the second page.
Sir.
Yes, sir. It is visible, sir. You can.
Yeah, and third page, case study 1.
Yes, sir. Yes, sir.
And this one, bridge.
Yes, sir.
Okay.
You can continue, sir.
It is continuous. Okay, okay.
Yes, sir.
Now, sorry for this all lesser knowledge what we have about this computer and all other things since we are not into this latest things here. Now, thank you for the Professor Sheshner for giving me an opportunity to present myself for this case studies of bridges and aqueducts, emerging trends in civil engineering for disaster management to the Department of Civil Engineering, JNTU. Now, let me start with this case studies for bridges and aqueducts. Actually, these have been carried out by my office. I hope all of you can hear.
Yes, sir. Yes, sir.
Okay. I will continue.
Sir, will you please zoom the PDF file, sir, if possible? In the top button.
Zoom.
In the top,
There
it is
is
there.
minus and plus buttons, right, sir?
In the top, in the middle, sir.
Top, middle. This
Yeah,
one?
yeah. That is okay, sir. Please click on it, sir. Please click on it.
Yeah, I clicked on this. This is the thing.
Sir, just hit escape, sir.
Escape. Okay.
Escape. Now, see, sir, there is minus and plus buttons there, right?
This one?
No, sir. Next one. Just hit on it, sir. Plus, yes. Yes, right.
Sufficient? Okay.
Yes, sir. Yes, sir. You
Just
please
scroll down,
proceed.
sir. While you are moving, just scroll the page.
Okay. Scroll the page. Okay.
Yes, sir.
Yeah,
Yes,
like
sir.
this, sir. Like this.
Now,
Good.
now it is good, sir.
I'll have to join the college again. Okay. Anyway, uh, now let me start with the case study one, where we have done the investigation. Can you hear? I think now we can hear.
Yes,
Good,
sir.
sir. It's good.
Okay, okay. Thank you. Case study of investigation rehabilitation of Marmur Bridge connecting Bangalore and Bangalore International Airport. This was the bridge actually. We did an investigation about 2 years back, I think. You can see here one of the piers here. One of the piers here went down into the river due to this covering action. Extreme heavy flow was there in the river bed. That's the reason it went down, and it had to be. It was about to collapse. Basically, it was. They suspected that it can anytime go down into the river. So that was an emergency case where we intervened and we gave the rehabilitation process. So this is the on the left side you can see this one, the profile of the pavement on top of the bridge, where it was not possible to even walk also there. And this is the right side. This is the profile of the bridge when the pier went down. Then the bridge is a vital link between the Bangalore city and Bangalore International Airport, belonging to Karnataka Public Works Department. Length of the bridge is about 180 meters. It has 9 spans of 20 meters each. The bridge has RCC superstructure with 5 girder configuration and a deck slab. Pier and abutments are of RCC. Piers are plate type. Pier and abutments are located on 2 RCC rectangle wells with a steining thickness of 450 mm. The depth of wells is 7 meter. Kindly note here, they were all old type well foundations. Now what you see, you can't see these wells nowadays because people are going for the pile foundations nowadays. 7 meter is what we assume based on our earlier experience, because people are not going beyond 25 feet into the riverbed, because it was very difficult for them to work below the 25 feet. So we assumed, and actually when we actually verified also, it was only 7 meter into the riverbed, into this sandy strata. The bridge is estimated to have been constructed around 1970. As such, it completed 53 years of its service. The sequence of distress was, it was extremely heavy rain, flooding in the river on 13th, 14th and 15th of 2021. Pier number 8 of the bridge suddenly sank into the riverbed by 700 mm on 15th at 2:30 a.m. in the early morning, and that is in the midnight. Precariously positioning the span number 9 and 8, traffic on the bridge, including the pedestrian traffic, was suspended. And it cracked up also on the top of the abutment near, and you can see on the right side, the railings broke. And there was a wide crack on the abutment because of the bending up of the deck slab. Hope all of you can hear. Hello?
Yes, sir. Yes, sir.
Oh, okay. Okay. The probable reasons for this cover in the riverbed are the location of P8 has reached almost 7 meter or more on 15, destabilizing both the well foundations, because one pier had 2 wells each under the pier, but they have not got washed out due to the water flow. That's a good thing that well foundations only settled down and they did not wash out. The well foundations as well as pier sank into the riverbed by 700, and also it has resulted in shifting of both the wells. Kindly note here, you can somehow manage to do the 700 whatever sank inside the bed, but 300 shifting, that is sideways, lateral shifting of 300, it is quite difficult to correct this lateral shifting, because those days they must have designed for all vertical loads and lateral loads. There must have been not a provision at all. But that this thing we will have to take into account, take some precaution and take a risk that the 300 mm, whatever lateral shifting has been happened, need to be corrected while doing the rehabilitation. The pier has become three-dimensionally eccentric. That is the situation as far as this pier is concerned. This one. Then result of that three-dimensional movement of the well of the pier resulted in the well cap broke in the middle of the, probably due to differential settlement of the two wells, because this has got two wells here. You can see here one well rectangle, other well rectangle. This settled more compared to the other one. Compared to the other one, one has settled more inside the riverbed. That has resulted in breaking up of the well cap here. Here, you can see here, there is a crack here, there is a crack here. These two cracks happened due to the breaking up of the well cap here. Please see, you can ask me any question in the midway also, a little bit, it's okay. No sound from that side. Hello?
Yeah, sir. Yeah, sir.
You are audible, sir. Please continue, sir.
Yeah. Please react a little bit here and there. Okay.
Sure, sir. Sure, sir.
Yeah. See, this is the problem where the well on left side, this is rectangle well. You can see the cap there, well on left side, well on right side. These are rectangular wells. They're all peculiar wells. Earlier, what we have seen, the circular well, octagonal well, whereas rectangle wells, and this is almost like a rectangle wells only, 2 numbers per pier. And this is the diagram what we made when it got into the riverbed and the side movement also, and it was you can see here, it was just the superstructure on the left side. You can see this left side, it was sitting hardly in the edge concrete of the pier cap started crushing due to the over stressing. Because of the extreme stress, it was just sitting, it was about to collapse actually, but somehow it was sitting by about I think about 200 mm onto the pier, that's all. Otherwise it would have gone down, actually crushed the pier cap and it must have gone down. Then precautions what were taken was, situation was very fluid, wells were sinking, structure needed emergency measure to stabilize the foundations, or else two spans can collapse any moment. Even pier along with the foundation can go into the riverbed or can get washed away. As an emergency measure, big size, almost 1 meter size granite boulders were packed. See here, we have lost the frictional capacity of the well foundations which are in the sandy bed of the river. So we need to create the frictional properties so that the wells will have friction to the sides. That is, soil structure interaction must be there. Earlier sand was there, now it is washed out. We need to put something. You can see here the boulders here, they were brought from outside, and whatever the scour happened in the riverbed have been packed and filled back with these boulders. Now the entire scour portion was secured using the boulders, sand and soil, and raised above riverbed by 5.5 meters. It gave us a little bit confidence that further movement, further sinking of the pier will not happen. So with having created a barrier so that this will not go down, now the already settled portion of the superstructure need to be corrected. So what we did was, immediately we procured some girders, that is railway supporting system like what you see here, and cribs. And after placing the cribs here temporarily, we placed some certain jacks here and lifted this portion on the left side span. We lifted it up and placed that entire superstructure onto the cribs. Even same thing we did on the right side also. So there was a gap above 700 mm gap was there above the pier without any support. But both the piers, both the superstructures were placed on temporary supports. The scripts acted as temporary supports. Then what we did was, then rehabilitation measures, having wells stabilized against further sinking, built up of overburden surrounding the wells, settlement of foundation further into the riverbed was ruled out. So that precaution when we took, we had some confidence that yes, bridge can be saved now. Here, there are rehabilitation measures which involve well cap, pier cap, and spans 8 and 9. So there are 4 items to be tackled for rehabilitation. Coming to back to one, the well cap needs to be rehabilitated because it broke. Virtually breaking means it was not taking any further loads. The well cap breaking, you can see here, there are 2 cracks. Anytime it can break, anytime the crack can propagate into the pier up to the top. That was the situation. So we need to do some exercise. That means stitch the existing well cap with a new well cap and anchor it to the pier also, like this. You can see here on the right side, this is the anchoring arrangement made. This is the existing well cap. This is the new well cap designed. And the strength of the concrete here, we maintained at M70 to see that this inside whatever broken lesser strength concrete is encapsulated using this new concrete and new reinforcement. That way it was strengthened. The well cap was strengthened along with the pier also. So this is where when we started using that sandblasting, so that it will have a better bond between the new and old concretes. With of course the bonding was also with the epoxies whatever used. This is actually the diagram because you can see here on the left side, the thickness of the pier, whatever encasement we did was more. On the right side, encasement was lesser, just because to maintain the center of gravity of the whole pier. One side it was more, other side it was made lesser, which did not have any effect on the well foundations because we had already fully given the frictional capacity to the well foundation so that it doesn't move at all. And this is one more drawing what we prepared for anchoring to the old and new concretes. And rehabilitation of pier rehabilitation carried out with sandblasting, chemical anchors, additional reinforcement was designed, application of structural grade bonding epoxy was put, encasing the pier using custom made M70 grade micro concrete. The new pier encasement got fully integrated with existing pier, well cap and wells also. And this is the picture of the rehabilitated pier. You can see here on the right side. Then we need to see here, you have a gap of about 700 mm which went down into the river. Then you have a gap and both the spans are simply stationed on temporary crib supports on both sides. So this cap was increased. The well cap was increased by almost about 700 mm to see that it comes to the original level of the pier cap. So that is the one exercise we made. Again, we designed the whole of the pier cap and it was attached to the existing pier cap. And so that on this pier cap. I will just skip here little bit. Again, the bearings were placed. After placing the bearings, we rested the pier, both the structures, both the spans on the neopron bearings. The neopron bearings were designed and they were placed below the gutters here, where we don't have such a photograph, but that what happened, I am telling you. And to check the strains in the pier, we provided FBG, fiber brag grating strain gauges, which are absolutely accurate at various levels to check the strain measurements in the pier, whether they are well in the limits or any breaking is there. So we were verifying that. And deflections in the beams were measured by LVDTs, linear variable differential transducers. Temperature was measured by the thermometer. Of course, the load testing was carried out there only to check the superstructure is in condition or whether it is transferring all these loads to the pier. So it was verified as per the load test of as per IRCS 37, and entire rehabilitation was carried out and heavy vehicular traffic allowed within 45 days. There was a resistance also from the public works department not to allow heavy vehicles. Only will allow cars or light vehicles, LMVs. So then I told them, when we have done such a hard job, allow in front of me only. I told them to allow the bigger vehicles in front of our team, so that public also will get confidence in using the bridge. So that way, rehabilitation was completed successfully, and the public works department thanked us. And in fact, the local MLA praised us so much, it came in the TV continuously for 2 days. Now, case study, I will just skip. I will just skip because again, it's a bridge. Let me shift over to Aqueduct, because some other day I will show this. Yeah, this is one of the important aqueducts which I wanted to show you for about 10-15 minutes. I'll show you or whatever possible here. The rehabilitation of aqueduct, 70 years old, washed out due to scour again. Washed out due to scour. This is a aqueduct, Hagri. It is just at the border of Andhra Pradesh and Karnataka. It's about 3 kilometers inside the Karnataka. Built in I think 1953 with the piers fully dressed stone and very neatly done work, unimaginable actually. This aqueduct has octagonal wells. You must see the photographs, you will be surprised. And the dressing of the pier with the fully dressed stones, I don't know, it is simply impossible nowadays to do, get these people and do it here. And that too, this is an aqueduct. It was not at all leaking, absolutely no leak at all. For it is about 750 meters. No leakage in any of the joints, nor in the concrete, even after, that is 50 means about 70 years. It is no maintenance also here. That this is due to the honest in executing the jobs. I can say it is a absolute honest. That's the reason it doesn't leak. If it were to be nowadays, certainly it would have leaked. And the details of aqueduct are, it's about 700 meter length. Vents are about 58 numbers. Clear span is about 10 meter. It is an old one. You can't expect to be too much longer spans. Then velocity of water is about 2.13 meter per second. Discharge in the aqueduct, kindly note here, discharge in the aqueduct is 1125 cusecs, is quite bigger in the aqueduct. Bed slope provided is 1 in 2000. And details of aqueduct, as I told you, it is a pier, stone masonry pier. Width of the pier is 1.3 meter. length of the pier. You can see here, dressed, so nicely dressed, circular dressings. I have not seen such a beautiful work for such a big size. And shape of the well cap is rectangle. Type of the well cap is RCC. Thickness of well cap is 300, which we don't do nowadays. Actually, for your kind attention, we don't do well caps or pile caps nowadays of 300 mm. This is 30 centimeter, 1 foot. And those days, whatever we have seen, majority of the even last whatever you have seen Mangalore, even that is also 1 foot. That is 300 mm, which we don't do, because nowadays our cap designs, well cap or the pile cap designs are based straight on the strut and tie method of designing, which requires about at least 1.25 to 1.5 meter thickness of well cap. That is what is the requirement here of Indian Roads Congress nowadays. You can see here, these are all damaged due to the settlement of piers due to the heavy water flow. It never happened. Hardly about 5,000 cusecs they were releasing in the river for the last about 50, 60, 70 years. But suddenly, I think last 2 years back, they released about 1 lakh cusecs on that particular day. 1 lakh. Where is 5,000? Where is 1 lakh? That has washed out. Cover was abundant, absolutely so much cover. Again, here also, this looks to be about 8 to 7 meter depth wells only. Each pier had 4 wells. Here, 4 octagonal shaped wells below each and every pier. Foundation details: well foundation, number of wells each pier 4 number, shape of the well octagonal, depth of well is 25 feet only. That is the problem actually. Here you can see the wells, aqueduct details are the foundation detail. Outer dimension is about 9 feet. Thickness of the steining. Steining means wall thickness of the well. That's called what we call steining. That's about 2 feet. Filler material is plugged with concrete at the bottom and top, middle portion with sand. That is well plugging, what we call. You can see here, these are the well foundations, 4 number of wells. I think meticulously calculated. There is no rough and tough method. Absolutely fully calculated. How much load coming from the top? What is the buoyancy? How much load to be transferred to the riverbed? 4 number, size of the well, everything they have done. In fact, their calculations are much better than what we do as we using our computers and all. Load considered for foundation is 1,000 metric tons. Type of soil strata is sandy. Kindly have a look at this. Please appreciate this. Some photos when aqueduct was under construction in 1952. Even my father, I think he worked in one of these Tungabhadra projects. You can see here on the left side, octagonal well, and all octagonal wells sinking. They are all sinking. Whatever you see here, rotating, they are all anchor this. Winches. They use the winches so that they will pull out the sand from the wells, so that the wells will sink into the riverbed. Hundreds of wells there. Some photos when aqueduct was under construction, some more. This clearly indicates sincere and honest work going on here. Agri aqueduct concreting on the right side. I told you, we have so many machineries, so much of super plasticizer, hyper plasticizer, so that water reducing agents into the concrete, and we have so many chemicals, so much of water reducing, so much of strength increasing chemicals also, whereas those days there was nothing but only cement. See here, cement and tamping. I doubt very much they had any vibrating also, a little bit, maybe they are vibrating. See here, hand on the head, she is carrying the concrete and she is putting it there, and they are tamping. And with this concrete, we checked virtually. This concrete have been checked by my office. See here, superstructure with bamboos, superstructure with bamboos. Agri aqueduct general view showing the pier. These are old photographs what we collected from the Tungabhadra dam authorities. From 8 to 27 of September, Aqueduct underwent severe distress as against 3 to 4,000 cusecs, 1 lakh cusecs of water passed below the aqueduct, resulting in the below distress. Pier P9, 10, 12 and 13. You can see here the distress condition. They were virtually about to collapse. See, you should appreciate one thing. This abutment, this aqueduct, water was flowing above the aqueduct. In the aqueduct, water was flowing continuously, whereas below the substructure had almost it is failed only, but there was no very high differential settlement was not there. That's the reason the aqueduct never settled by 1 mm also, and straight away the water was flowing in the. It is the goodwill of the farmers. Nothing happened here. Then same one more this one. Here what happened was again I am showing various distress conditions. See here. Here various distress conditions. See here it is as good as collapse only. For our technical reasons it is collapse. Here you see here they were all cracked up and so much water was passing through. On one fine day what happened was this engineers noticed on date 13/10/22, pier number 15 completely washed out, but the superstructure is still standing without any distress. You can see here there is no support at all here. Water is passing inside. Kindly note, water is fully passing. Water weight itself may be about 100 tons. 100 tons plus 100 to 200 tons of load of water is passing through the aqueduct. And there is no support at all here. Absolutely no support. It is standing like that only. Even I went there. No, it is an engineering thing. It is due to the compressive action of the rectangular portions of the aqueduct that must be holding the aqueduct in place. And that's the reason. Again, I tell you, it's a goodwill and God's grace. It didn't collapse at all. It never came down. And water was flowing to the crops. This is one more photograph. And here on the top, I went on the top. You can see water flowing in the aqueduct. And this is the pier. This is the pier. Below this, it had washed out. But the superstructure is still standing. Various rehabilitation measures were thought of, and it was a very dangerous situation to go below both the spans. It was absolutely because there is no support. It can come down any moment. Then the proposal was whatever washed out portion below, that is this covered portion, was packed with the boulders, with the sand, and we put some high girders here to give a support to the pier portion, so that whatever the earlier pier portion was there, this portion needed to be supported by some method so that the water load and the superstructure load it can take. Then we designed, actually, we had plenty of experience in the lifting of bridges. We used to lift a lot of bridges for replacement of the bearings. So we had plenty of experience. Then we brought some timber and tested the timber for its compressive strengths. Then we cut the timber at a nearby mill and we prepared the ground for putting this timber so that the load on the top can be transferred onto the timber. Same time, what happened was Morbi Bridge, you must have heard in the Gujarat, it killed about 141 human beings, Same time, almost near this or that side, it had a serious physiological, psychological impact on the investigation and rehabilitation of the aqueduct due to below photographs which were from the site on 30th, the day of Morbi bridge collapse, and everybody was afraid to go below the bridge, below this our aqueduct. Nobody was prepared. Then somehow we managed. Various rehabilitation measures were thought of, but as an emergency measure, it was proposed to boulder fill. And as I told you, this timber thing and some steel plates were given at the bottom. And this was the timber. You can see here some sand filling, boulder filling, and of course timber. This is the pier where it disappeared. The pier itself disappeared. After disappearing, it started leaking slightly, not very much. So you can see here, we kept 4 jacks and we lifted the whole, both sides of the superstructure of the pier where it collapsed were lifted up. Special hydromechanical jacks were used. These are all special jacks where it works on hydraulic as well as on the mechanical system. Was specially introduced by my office here so that we can lift up. You can see here, after placing the jacks, one of our minister here, the white shirt minister, he came down and he sat there below. I told my staff to remove everybody from below because it's very dangerous to sit freely below and discussing about this problem. Then this is one more photograph where all the supports were given. Once the supports are in place, then there is no issue at all because only it has to be properly rehabilitated later. This is the pier, and again additional supports were given, crib supports on both sides, so that we can start the rehabilitation for of this pier. This is one more picture of the pier support with the timber and steel girders. Then we were supposed to give support there below. This timber support cannot continue for continuously. So what we did was we provided. I'll show you. We provided here 4 piles on the upstream. These 4 piles. Then we provided 4 piles on the downstream, both sides. 4 piles this side, 4 piles that side of the river. Then we connected both this with a pile cap. Then we connected the left side and right side with steel girders, so that loads get transferred onto the girders and onto the pier cap, so that pile cap, so that the piles will start taking the load of the aqueduct. We did it for almost about 7-8 piers. So that way it got transferred, load got transferred onto the, see, this is one more picture. This is the only way out then, because you cannot raise anything below. It's always covered. You can't get anything there. We provided these piles up to the extent of below in the sense, we took the piles up to the rock level, which was about 18 meter or 20 meter, and we made the socketing there and they were raised from that level. So it was out of the fear. You can see here pile caps on the left side. So on the left side as well as on the right side, and the angles, this structural steel was put there to transfer the aqueduct loads onto it. See here, even we continuously did that. Nothing, water continuously was flowing in the aqueduct. This is, you can see on the left side, same quantity is also flowing below the road there. You see on the right side, same quantity, because the aqueduct normally will have a vertical wall in the middle. So this is the vertical wall, and this is the aqueduct. there is one more opening on the right side, which is below the road. Same quantum of water is flowing there also. Now, I think some other day I will be able to show you the case study. These are all small things. I think this should be sufficient for today. The aqueduct emergency, how what we have taken care in rehabilitating that. Thank you, sir. Professor Shashidhar.
So,
Professor, can you hear?
Sir. Thank you very much, sir. Sir, if you allow, I welcome participants for question and answer session, sir.
Yeah, please. I will be happy.
Yeah. Dear participants, I am requesting you all, please raise your queries if you have. I welcome the participants for a question and answer session. If you have any questions, please text on chat box. Sir, there is a question from Abhinav, sir.
Yeah.
If pilot test was failed on working pile, what shall we have to do in this site?
Fantastic question from a, I think, good question actually. If say there are two types of piles, piles you will have to put in any of the structure, any structure, either the building or the bridge or aqueduct. Two types of piles. One pile, before commencement of the work, you will put it. That is the initial pile. Initial pile we put to see that to capacity of the initial pile to see that whether the piles proposed in the project will go take the loads or not. This initial. So initial pile, there is no pass or fail. Initial pile, only you will know the capacity of the pile based on the localized soil condition. So take that loads, then design the pile, then you execute the balance piles. Okay, coming to your point. Now, suppose the routine pile, in a routine condition, if the pile fails, if the routine condition pile fails, you will have to go for additional two piles to cater to this single pile. And don't stop at that location only. Kindly investigate backwards whether the pile was designed properly, whether the C5 values, that is the soil characteristics, was taken properly, and whether the pile itself was structurally designed properly. All these things need to be investigated backwards. Then you decide on the additional two piles. One pile failure, you will have to put out two additional piles. And that is a common thing in the industry.
Sir, there is another question.
Yeah.
Yeah. Epoxy is the major uses for RRS. It's used for peer rehabilitation.
Sir, repeat again. Epoxy.
Yeah, question is not clear, I think.
Yeah.
Epoxy is major uses for RRC, I think it seems. Is it used for peer rehabilitation?
Yeah. Epoxy is a chemical which bonds between the old and new concretes. And in this case, like Marwar Bridge, I think you are speaking about the Marwar Bridge. In the Marwar Bridge, the epoxy is used between the old and new concretes to have a better adhesion. And of course, encasement, it becomes one old pier and new concrete, whatever encasement we are doing, it becomes one. And it gives lot of adhesion characteristics, and which we have used continuously. I think tons and tons we have used, and it gives very good result. In addition to that, epoxy, that is a chemical bond, what you call. You will have to go for the physical bond in the form of anchors.
Yeah, there is another question from AP Sarma.
Yeah.
Sir, he is asking you to comment on the stability of bridges in India and the responsibility of both the state and central government. He would like to comment on it.
I would like to comment. He will comment, sir.
No, he is asking you to comment on it.
Yeah. See, stability of bridges are concerned. Normally, we check the bridges twice a year, and it is state government or central government. We have separate responsibilities. Separate whoever is the owner, his responsibility stands on that. Here, in this case, the national highways, the expressways, and whatever the taken over highways, taken over in the sense from the state government, we shift some lengths of the roads to the national highways. When we shift it, automatically the ownership changes to them, NH, or national highways, or a National Highway Authority of India, NHAI. That time they take care because they are the owners. And stability wise, we check these structures yearly twice. Sometimes some special investigations are carried out every I think about 5 years once, completely detailed analysis.
Yes.
And we have a code, revised code. Only the last year we released IRCSP 37. So we carry out all inspections as per that 37, and we certify.
Yes. Sir, there is a question from Dr. Naidu.
Yeah.
In aqueduct rehabilitation work,
Yeah.
what are the measures to be taken for other peers?
See, I will tell you, this was a peculiar case in the aqueduct. Other piers were all in very good condition except this 7-8 which went down into the river. Apart, what we did was we neglected the load carrying capacity of the pier itself. For those 8 piers, we have 100% neglected. We put 8 piles, 4 on that side, 4 on this side, connected both by a structural arrangement, and that structural arrangement was made to take the load of the aqueduct from the top. Other than that, there was no rehabilitation done for the piers. We didn't do anything, and we never recommended also. In fact, for your kind information, we recommended for removal of all the encroachments by these farmers into the river. Strictly, we told either you remove it or you don't do it. Again, you will end up in the same thing, because that has to be done by the revenue authorities. Because farmers had already occupied from both the banks of the river and came down into the river so much that made the flow in the river to constrained, and the velocity increased. I think it increased so much, it cut into the sand in between the piers, and it removed the entire thing's cover. Its cover cannot happen for 25 feet and all. It cannot happen. It happened because of the local population, and these our engineers should have controlled. In fact, they tried to control. I think there was some problem because these farmers are a bit stronger there. And in fact, I recommended for complete 100% removal of the encroachments from there, so that the width of the river is maintained, so that the velocity in the river is always to the original whatever velocity. See, hundreds of years nothing happened. Only now it happened because of the constraints created by our human beings. Yeah, we are very always eager to knock off the free whatever available there. That's the reason this scour happened. And other, as you told, the substructure, that is piers, no repair was recommended. Sir, I will tell you one more thing. We checked the entire aqueduct completely. pH values were well within the limits, and I had given in writing, I gave to the Tungabhadra board that this structure, which has already completed 70 years, is going to complete 70 more years without any major distress or major repairs required, because It was done so nicely, fantastically. Sir, next question, sir.
Yeah. Yes, sir. There is a question from Saya Abhinav.
Yeah.
Though the static payload test met the permissible limits on site, if the dynamic payload test indicates failure,
Yeah.
is it necessary to provide additional piles to compensate for this failure?
No. Sir, once more you tell me, sir. Let me fully understand.
Though the static payload test met the permissible limits on site,
Okay.
dynamic payload test indicates failure.
Failure. Okay.
Yeah. Is it necessary to provide additional piles to compensate the failure?
No. You kindly delete that dynamic payload testing and go ahead with the static payload testing, which you have already completed in the initial pile or routine pile or whatever. Dynamic payload testing shall be taken as an additional test only, and in case if the pass or fail of the dynamic testing need not be considered or to check the static pile testing, because static pile testing is always superior and dynamic testing need not be considered. It shall not be considered, to be frank.
Okay. Thank you, sir. Sir, there is a question from Nivedita, but question is not clear. I
Yeah.
request Nivedita to unmute yourself and ask the question.
Yeah.
Nivedita, are you there?
Yes, sir. So, good evening, sir.
Yeah. Good evening, madam. Tell me.
Sir, what are the safety measures for bridges in India, sir? Nowadays, more damages are occurred, right, sir?
Yeah.
So,
Nowadays, a lot of collapses are happening actually.
yes, sir. Yes, sir. Yes, sir.
Because see, earlier we were doing say about 100 bridges. Now we do 1,000, 2,000 bridges. Out of 100 bridges, one or two bridges somewhere something is going wrong, like hydraulic failure or this failure, that failure. It was collapsing. It was not being noticed because nowadays more bridges, more collapses. So the safety factor, whatever to be increased, has already been put in place actually by the NHA, by the state governments, as well as the Ministry of Road Transport Highways, and all are concerned basically. In fact, last time Indian Roads Congress seminar about a month back happened in Raipur. There also we discussed. There was a panel discussion on the quality control of these things, the bridge construction, as well as the safety measures required to see that the accidents do not take place. Now we are not up to the mark of the Europe and America, where these safety measures are quite higher. And now at least you should appreciate from last, I think about 5 to 6 years, the safety things are coming in a very big way actually in our country also. In fact, earlier safety boots were not there to the workmen. Now, without that, they don't allow. Now, the certified machineries only will enter the construction site, which was not there, but now it is there. Unless until these things are there, they don't allow. Then you have safety book itself separately, what to do, what not to do. Everything is there. That way, lot of precautions are in place now, and it is going to improve basically.
Sir.
Yes, sir. Thank you, sir.
Yeah.
Sir, I have a question to you, sir. I'm looking for some suggestion.
Yeah, please.
Sir, just I want to know that how to minimize this cover. That is a big question.
Yeah. May I know your name, please?
I'm Dr. B. Ravinder, sir.
Sir,
Yes, sir.
cover minimize. It is a natural. See, cover minimizing. That means we should not restrain the river. We should not constrain the river from both the sides. We should allow the river to flow on its own. So once we do not disturb the river, this cover, whatever original was there in about 50 to 100 years back, same thing will follow even now also. The human beings are very avaricious. They want to make early money and early take away somebody's property. That's the reason even in the same that aqueduct that cover happened. And this cover, it is we can't. We can't do anything. Cover is again the velocity of water, quantity of water, and imagine cover. We have actually we have those calculations, velocity, everything is there. But despite that, when structure like this, aqueduct or the bridges are there, we should not create something especially on the upstream. Downstream, there's no issue. Upstream, we should be very cautious not to increase the velocity of the flow of the water. That way, you can control.
No, thank you very much, sir. Because there is some situation which has impressed me to ask you this question.
Yeah.
One of the which has been taken up by the government of Telangana.
Yeah.
One project, because I mean, there is a conflict was going either maybe political. We don't want to get into that.
Yeah.
They were saying that because of this cover, the structure got collapsed. They are saying that cracks have been developed because of this cover.
Yeah.
The project is Kaleshwaram, I think, if I'm not wrong. So they were talking hue and cries going about that project. At middle of the structure, whatever you are shown in the presentation, there is a settlement place. Cracks have been developed.
Yeah.
So for this, because it is being newly developed project, and it was stagnated one place, and it is a lift irrigation project. So there's no water flow. So cover has took place. That's what they are saying. The project is being carried out by L&T.
Okay. Okay. Okay.
For this reason, I was curious to ask you how to minimize the scores, sir. Nothing more than that.
No. These are the only things. No, suppose you get such a thing, send me one email so that if you ask me any question, I should be able to answer.
I take an email from you. Possibly, if you are able to.
Some photographs of and those details, if you send me, because we have gone through so much in this Tungabhadra, Marur, all so many bridges, and nowadays the biggest problem is not the cover actually. The biggest problem is removal. That means creating a cover in the riverbed by selling the sand, by pulling out the sand from the there and selling out. That is the biggest headache to the government now, because night and night they will remove. They get machineries, they pull the sand from the riverbed and they sell it out. That's a big headache. In fact, tomorrow also I am going for Mangalore for rehabilitation bridge, which was damaged by the same sand mining, what we call sand mining. Cover is not a big problem. That is not a devil. Devil is our human beings only. They are removing the entire sand from the bed and they are selling it out. That's a big headache.
In this project, the sand was not lifted because of the water flow. The scoring took place at the bottom of the structure. Because of that, the sand, the structure got settled. That's why the cracks have been developed. That was projected in the media.
Yeah.
So, if you are able to share your email ID on the chat box, it will be great.
Sir, chat box, I am poor in this chat box. I don't know how to manage, but I can tell you small SG.
Sir, shall I share your email ID in the chat box, sir?
Yeah, please go ahead.
Yes, sir.
Thank you, sir. Thank you very much for that.
Kindly send a mail, and suppose Professor Shashidhar is always be in touch with me. In case if they know the response, then you can call him, and he will again communicate with me. I will see that such any difficult situations we can come out.
No, see, so I'm not directly involved. Like I'm being into academics as well as I'm being into the contracts. I'm very much interested to understand. That's it, sir.
No problem, sir. The only thing technically we should enhance our thing, our educational whatever engineering things keep on the higher level.
Yes.
Commercially, we not there at all.
Thank you, sir. Thank you very much.
Thank you.
Yeah, sir. Sir, we have mentioned R.K. Rajagopal sir mail ID in the chat box.
Jai Gopal.
Jai Gopal sir mail ID in the chat box. Sir, there is another question. If you allow, I will read that question.
Please go ahead, sir.
Yeah, there is a question from Dr. Wanga Mohan Gaud. Sir would like to know which bridge you considered is an ideal one in the past decade and why?
This is a pakka question from a teacher. Which bridge you consider an ideal one? I consider a bridge as an ideal one which has not cracked, number one, which has not settled, which has not deflected. These are the physical things. And I also consider where the pH values of the concrete has not gone down below 12.5, even after about 60 to 70 years of its service. And the corrosion levels in the reinforcement has not gone down below with the electrochemical Hobson potentiometer readings less than 300 negative millivolts. Those are the physical characters required so that I can take it as an ideal one, which you can say which are the bridges. Some of the bridges are there in the Karnataka, where we have seen, even in Andhra Pradesh also it is there. Karnataka, especially on the Mangalore coastal side, we have bridges with the specifications what I have told. No deflection, no cracking, no corrosion, and no carbonation. Now, in the sense, they are all under control even after 50, 60 years. But you don't get such bridges, sir, nowadays, because those bridges were built with highest honesty. That's the reason nothing happens. And nowadays, bridges are not built with honesty. That's the reason you have all sorts of available problems here. That's all, sir.
Yeah. Is there any question from the participants? Yeah.
Sir, even if you think that there is a question afterwards, don't bother. Anyway, email ID is there. You put a question, and if I get it, I will be very pleased to answer, because all our faculties, and I give very highest prominence to the faculty, because you teach so many students, and if you know these things much better, you should be able to deliver a good education to these students also.
Great, sir. We are thankful to you. Already we provided your mail ID in the chat box, sir. Participants will access your mail ID through chat box.
Yes, sir.
Right. With this, I would like to conclude, sir, by seeing this nice interaction of participants with you. It is very clear that you left a lasting impression on every participant present here. We really inspired by your contribution, which played a significant role in the success of our program, sir. On behalf of organizing committee from JNT Anantapuram and SRIT and the participants. Hello.
Raghu, am I audible?
Yeah, sir. Yeah. Sir,
So
over to you, sir.
yeah, thank you, Raghu. Sir, Gopal sir, thank you very much for sparing your valuable time.
Yes, sir.
With so many questions, we can assume like how much interest your presentation is. In fact,
I'm happy, sir. Yeah.
You are helping all our students as well as faculty. So thank you very much for your expertise in delivering this lecture, sir. On behalf of JNTU and ATAL FDP program, and once again, thank you very much for sparing your valuable time and delivering the lecture, sir. Thank you very much.
Yes, sir. Thank you. And sorry, in the beginning, there was about 15 minutes delay in the presentation, sharing and all problem. I'm not a computer man. That's the reason. I took some help in telephone.
No, sir.
Yeah.
You shouldn't.
No, sir.
But you are a bridge man. That is the topic of so bridges, how rehabilitation of bridges. That is the topic, and you are perfect of a bridge man, sir. That's what we can see. Yeah? No issues, sir.
Sir Jai Gopal, sir, there is sir, 1 minute, sir. Sir Shashidhar, sir, 1 minute, sir. Sir, one of students who went for internship at Shimla, they have been interacting with NHI ROs at that point. They are very proud that they have seen your name in the IRC code books, and they are very happy that you are directly connected to them, and they are proudly saying that Jai Gopal sir and we are directly connected, and JNTU students are very proud that Jai Gopal sir has given us all valuable suggestions by establishing IIB student chapter and all those things, sir. We are very happy with your suggestions and all.
Thank you very much.
What Yogi is saying, sir, our students have went to internship at Shimla. There they referred your name to the company, like this sir is directly connected to us. It was a proud moment to them, and they have well appreciated because we're directly connected to JNTU.
Yeah. I am also proud that I am connected to JNTU. And professors like you, I'm happy to interact and all. Yeah.
Thank you so much, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir. Though your starting is trouble, your ending is fabulous.
Yes, sir. Thank you.
Thank you very much, sir.
Yes, sir.
Really, we are getting very good appreciation from participants, sir.
Yes, sir. Shortly, I will also be. Professor Shashidhar was asking to deliver some sort of a lecture there. Now, let me just check up the dates and the topic where we can deliver some at least half an hour, 1 hour for your student chapter.
Yeah.
We are becoming along
Yes,
with our.
sir.
And,
Yes, sir. Please give your valuable time, sir.
Yes, sir. Sir, 9th, next month, 9th, there is a workshop on the limit state design.
We are coming. Yes, sir. We are coming, sir. We are coming.
Yes, sir. Thank you, sir. Thank you, sir.
Right, sir. It is our privilege of working with you again in future, sir.
Yes, sir. Right, sir. Thank you. Thank you very much.
Right. Dear participants, we have posted the feedback links in chat box. Please fill the Google form in a stipulated time. Sir, is there anything else to talk?
No, sir. No, that's all, sir. Thank you.
Thank you. Shridhar, sir.
Sir is still in office. We'll close the session.
Yeah, okay, sir. Okay, sir.
Yeah.
Yeah, I'm placing the feedback link again. Yes, we have provided 2 feedback links in chat box. Please copy it and fill the Google form. Okay, with this we are going to conclude this session. Thank you everyone. We will meet tomorrow.
To use Premiere to create a prose-based visual montage, like a video poem. To do that, we collaborated with one of our poet friends
to write a few paragraphs of verse with which we shot footage against.
We used text-based editing to edit the prose into the final montage form.